What is the meaning of differentiation in mathematics? Differentiation is a method of finding the derivatives of a function. It is also a process to find the instantaneous rate of change in functions based on one of its variables. Next, the techniques of differentiation that we learn is, first, the product rule. Product rule is used to differentiate a function that is a product of two differentiable functions. Second is a quotient rule. Quotient rule is a method for finding the derivative of a function that is division of two differentiable functions. Lastly is chain rule. Chain rule is a technique for finding derivatives of composite functions. The number of functions that make up the composition determine how many differentiation steps are necessary. As we can see, there are two cases of the chain rule. First is a functional form of prime notation. It is best used for mental visualization and quick calculation. It is highly efficient when dealing with nested functions. For the second case, it is a Leibniz form. It is for complex problems and multivariable calculus. It makes it visually obvious how units or rates of change chain together.
For question 2, we are going to look into two methods of differentiation. The first one being the product rule and the second one being the derivatives of trigonometric and exponential. Question 2 tells us to differentiate the following functions with respect to x. For part A, the equation given is 5x cubed multiplied with e power of cos x. The first step is to identify which method of differentiation we should use. In this case, we use the product rule. To solve this, by using product rule, we have to identify u, v, u prime and also v prime of the problem we are looking at. Here, we can say that u is 5x cubed, v is e power of cos x, while u prime will be the differentiation of u, which is 15x squared, and v prime will be e power of cos x multiplied with negative sin x. The next step is to substitute the u, u prime, v and v prime into the product rule formula, which is dy over dx is equal to uv prime plus vu prime. After substituting, we shall factorize the equation we get, which will be 5x squared multiplied with e power of cos x multiplied with negative x sin x plus 3. Lastly, we can rearrange the equation to get 5x squared multiplied with e power of cos x multiplied with 3 minus x sin x, which will be the final answer. For part B, we need to differentiate fx equals to ln 5x over sin 2x. First thing first, before we start solving, let's rearrange the equation of fx to ln 5x minus ln sin 2x. Now we can start solving by differentiating the ln 5x. We differentiate ln 5x, we're going to get 5 over 5x. Then we differentiate ln sin 2x to get 2 cos 2x over sin 2x. Next step, simplify the equation we got to have 1 over x minus 2 cot 2x, which is the final answer.
Hi, I'm KARMILA and today I'll be explaining about implicit differentiation. As you can see, this is the general formula that we can use, so make sure you remember. Why and when do we use implicit differentiation? We will use implicit differentiation when some equations are impossible to solve for y and it can save a lot of time and effort. Question asks us to find dy dx using implicit differentiation. So for the first step, write by the equation given, which is y sin 2x minus ln 2y equals to 2x squared plus 3. Next, substitute the value into the implicit differentiation formula. We need to differentiate both sides with x. Let's break down term by term so that we can understand it easier. For the first term, we will use product rule, which is dy dx equal to vu prime plus uv prime. After calculation, you will get sin 2x plus 2y cos 2x at the first term. For the second term, we will use chain rule, and at the end you should be able to get 1 over y dy dx. Let's differentiate the third term as usual. Bring the square to multiply with 2 and you get 4. x2 minus 1, you'll get 1 and 3 becomes 0. Next, what you need to do is substitute the differentiate value of all three terms into the equation again. After that, move all terms that contain dy dx to the left side and other terms to the opposite side. This helps us to calculate easier. Next, you're gonna factor out dy dx from the left side. After you isolate dy dx, bring sign 2x minus 1 over y to the right side and divide it with 4x minus 2y cos 2x. What you're gonna do right after is multiply both numerator and denominator with y so that we can remove the fraction for clearer expression. For the final step, you have to multiply with y, and the final answer is dy dx equal to 4xy minus 2y squared cos 2x over y sine 2x minus 1. And that's it.
My name is NAZRATUL HAZRIN, and I'll show you how to solve a question using linear approximation. And this here is the linear approximation formula, so make sure you memorize it. But how does the formula works? This formula represents the equation of the tangent line to the curve at x0. For values very close to x0, the tangent line and the actual curve are nearly identical, making it a powerful tool for quick estimations. So here, the question asks us to use linear approximation to estimate the value of the fourth root of 15.98 minus 2 divided by the square root of 15.98. Here, the x is the given value, which is the 15.98. The x0 is the chosen value, which is 16. We choose 16 because it is the perfect fourth roots and square roots. Lastly, delta x is the change in x, which is x minus x0, which we get negative 0.02. So step 1, define the function of x. Turn the expression into a general mathematical function by replacing the variable numbers with x. This gives us f of x equals the fourth root of x minus 2 over the square root of x. To make it easier to differentiate, we rewrite the roots as exponents, which give us f of x equals x to the power of 1/4 minus 2x to the power of negative 1/2. The second step is to find f of x0. For this, we substitute our chosen value x0 equals 16 into the original function. As you can see, f of x0, which equals f of 16, equals the fourth root of 16 minus 2 over the square root of 16. And then, we simplify the roots to give us f of 16 equals 2 minus 2/4, which then simplifies further to f of 16 equals 2 minus 0.5, giving us a final Pesulin value of 1.5. Step 3 is to find the derivative f prime of x. Using the power rule, we'll differentiate the function to find its slope. When we apply the power rule, we get f prime of x equals 1/4 x to the power of 1/4 minus 1, minus 2 times negative 1/2 x to the power of negative 1/2 minus 1. And by simplifying this, f prime of x equals 1/4 x to the power of negative 3/4 plus x to the power of negative 3/2. And finally, we rewrite this with positive exponents in the denominator to make evaluating easier, which gives us f prime of x equals 1 over 4x to the 3/4 plus 1 over x to the 3/2. Moving to step number 4, find f prime of x0. Substitute our chosen value x0 equals 16 into the derivative function to find the exact slope at that point. This sets up our equation f prime of 16 equals 1 over 4 times 16 to the power of 3/4 plus 1 over 16 to the power of 3/2. Next, simplify the first term. 1 over 4 times the fourth root of 16 cubed equals 1 over 4 times 2 cubed, which is 1 over 4 times 8, give us 1 over 32. Now let's simplify the second term. 1 over the square root of 16 cubed equal 1 over 4 cubed, give us 1 over 64. And now all we have to do is to add the fractions together by binding a common denominator, which we will get 3 over 64. Finally, the last step is to apply everything that we have calculated back into the linear approximation formula. As the result of this, we will get the answer here, which is 1.499. That's all. Thank you for watching.